Today we have Carbon Reduction through Electrification Part 1, our electric design and construction series with Jennifer Rennick and Andy Pease from Inbalance Green Consulting. My name's Ital Torres, and I am with the 3C Ren team, and we're really happy to have you all here. Next slide, please. We ask that everybody make sure they are on mute throughout the duration of the course. If you would like to verbally participate, please raise your hand in the participant section and we will call on you to unmute yourself. We encourage you to participate and ask questions through the chat box as well. Next slide, please. A little bit about 3C Ren for folks who aren't familiar with who we are. We are the Tri-County Regional Energy Network, a collaborative partnership between San Luis Obispo, Santa Barbara, and Ventura counties, working to improve energy efficiency in our region by offering free programs and services for building professionals and households. 3C Ren is funded by ratepayer dollars, which are collected to the public goods charge found in our utility bills. Next slide, please. We currently have 3 programs. First one being the Energy Code Connect, where we offer industry trainings, regional forums, and Title 24 consultation service called the Energy Code Coach to help building professionals navigate the California Energy Code and green building requirements. The phone number is listed on the slide right there, and it's our Energy Code Coach hotline. And there's also an inquiry form on our website. Our next program is Building Performance Training. We offer trainings on technical and soft skills related to building science principles and systems for high performance building. Our goal is to bring industry recognized certifications and training providers to the Central Coast that will help advance people wherever they may be in their career. And last but not least, our home energy savings program, which serves households that are historically underserved with free and discounted home energy upgrades. If you or any of your clients are looking to make energy efficiency or electrification upgrades, please check out our website to find an enrolled contractor. And with that, I'll hand it over to the Imbalance team to get us started today. Thank you so much.
Thank you so much. I'm Andy Pease, and I'm here today presenting with Jennifer Rennick, and we're thrilled with the ongoing partnership that we've had with 3C Ren to be able to provide ongoing continuing education and training, as well as the Energy Code Coach services. So we maybe a year and a half ago worked with 3C Ren to develop a series that would be specifically targeting the compliance with the zero net carbon design requirements of the California Architecture Board. So in order to renew your license, you need your architecture license, you need 5 hours of continuing education in ZNCD, as well as access compliance. We're not doing the access compliance side, but we want to be able to offer that. So we did that course, and then now it's kind of come around again where folks are needing their hours, and there's so much that's unfolding within the operational carbon of the building electrification that we developed a series that's specific to that. So if you are an architect, this will fulfill that requirement, and it also provides the whole series, 5 learning units for AIA, health, safety, welfare. Next slide. Awesome. So we'll go ahead. I see Soham has joined. I'm just so happy. Soham was our intern for a long time, and he's really fun to check in. So here's the outline of the whole series. Today we're doing the overview, carbon reduction through building electrification. So this is a kind of the macro view, the why are we doing this? How is this part of a bigger solution? And then the next 4 courses are all very specific to buildings and kind of what we do on a day-to-day. But today's is more of a setting the stage and providing some background and almost justification for that type of work. So next, Jennifer, if you are an AIA person in San Luis Obispo and you are interested in doing this course in person, you can, the AIA San Luis Obispo is hosting an in-person class. It's going to be 2 mornings, 2.5 hours each on October 10th and November 7th. And so it'll be this exact same content. So if you prefer getting your course content in person, it will still be free. It'll come with coffee and baked goods, and you're welcome to do that. So if you decide you'd rather do that and you're already signed up here, just drop a note in the chat so we'll know what your intent is, and then you can go about the rest of your morning. Otherwise, we'll keep going with the online. So here's the learning objectives in terms of for the whole series, about the why behind this shift that we've talked about. There's a lot of content on here, and yes, we will send you the slides later. It's also being recorded, and so it will be available on demand. So you can also circle back that way. And here's the agenda for today in terms of zero net carbon design and the clean energy goals, where that's coming from, the specific to the grid. Then we'll talk about ZNCD and transportation and why that is now so much more relevant to architects and builders than it ever was in the past. And then we'll start to touch on buildings, just kind of a preview with a few case studies, and starting to look ahead to how we're going to proceed with the next 4 in the course. And with that, I'll turn it over to Jennifer to launch us through these next sections. Thanks.
Everybody, and welcome. Before we get started, I just want to remind folks that a lot of the angle that Andy and I will take on this presentation really is kind of that of an architect. We're both licensed architect. Andy's lead AP, and I'm also a certified energy analyst. So my specialty in architecture has turned out to be Title 24 energy code compliance. Go figure, but architects do all kinds of things. But as I talk about zero net carbon design and California's clean energy goals and how we get our electricity, and also the impact of the types of energy we use in California, I'm going to be thinking about it also as that perspective of how does this relate to architecture and to architects. And before I jump into that, I wanted to remind folks about some vocabulary that you might see sprinkled throughout the presentation. And just in case I don't specifically emphasize the definition of these words, I wanted to go over this so we're on the same page. So ZNCD, we're using that acronym a lot, zero net carbon design. We're going to talk about what does that mean throughout the presentation. Global warming potential, GWP, you'll see that on some of the charts, and it's a metric that uses carbon dioxide equivalent, and that equivalent carbon dioxide is considered to have a baseline of 1, and it's a common metric for refrigerants. Although we won't get into the refrigerants so much today, it will be coming up in the future presentations. And then greenhouse gases and greenhouse gas emissions, we often talk about it in terms of CO2, carbon dioxide, but there are 7 components altogether that we consider greenhouse gases and are monitored for greenhouse gas emissions. And then specifically when we talk about non-combustion, or you'll see on some of the charts that are produced from the state and federal agencies, they'll also have a category called high GWP, and that means typically refrigerants, but sometimes methanes that have a high global warming potential value to them. Fossil fuels is everything. It's the gasoline, the diesel, the natural gas, propane. It's all of it. Operational carbon, specifically, we're talking about the energy that we need to operate the buildings. And embodied carbon is the emissions, greenhouse gas emissions in a CO2 equivalent that's related to the building materials and construction itself. Clean energy / clean electricity. We're just talking about electricity produced or energy produced without emissions. If you hear the word clean fuel, typically we're talking about hydrogen fuel cells. And decarbonization, it's used a lot in the language that the state uses, and it just basically means the elimination of those CO2 equivalent emissions as a method of mitigating for climate change. Few acronyms on the side, just as a reminder, and you're going to get a copy of the slide deck so that you'll have this handy when you go back and take a look at things. But before we dive into some kind of the nitty-gritty of clean energy and the transition to clean energy in California, I want to start with like setting the stage. And as an architect, this is kind of how I think about it. People, buildings, and everything, right? And so people and buildings are key in my mind. So we've got a person or a group of people. And what do we need as a person to survive? Kind of the basics is water, food, shelter. And it's assumed that in the background, we have clean air. And when it comes to our water, we know that when water is delivered to us into our buildings, there's energy that goes into pumping that water, and there's energy that goes into cleaning that water. And there, of course, is an effort to maintain clean water in the first place. And with food, we have agriculture and forestry practices, but we know there's processes involved with harvesting and transporting and processing those products and getting them out to market, essentially, and to people. That involves all types of energy. And so when we talk about energy in general, you might see an icon like this that looks like a power plant, but really it could be natural gas, it could be nuclear, it could be solar and wind, hydroelectric, gas, diesel. All types of energy are a part of our environment. And it's how we power our buildings. And then, of course, how we move ourselves and our products and how we transport all these materials is all categorized under transportation. And by shelter, really what we're going to talk about is buildings, all kinds of buildings, and their operational and embodied carbon impact. So that includes the electricity that is used to power up those buildings, the natural gas that's perhaps burned directly for those buildings, the refrigerants that are involved in all the heat pump technology we're going to be talking about, or air conditioning, and other industrial processes that require refrigerants, and of course the building materials and the manufacturing themselves, which is part of the embodied carbon impacts. Okay, so that kind of sets the stage, because really when it comes to our buildings, they are a piece in this giant thing we call civilization, which is, in my mind, it's like everything. And then that civilization is in the earth and in the world, which encompasses the rest of the everything. Now, when it comes to tackling kind of the problem-solving process for reducing greenhouse gas emissions, is first, very intelligent folks, scientists, and many policy people and government officials, they're looking at what is this problem that we're noticing where we have extreme climate weather events, climate change, global warming. an ocean that is absorbing CO2 and becoming more and more acidic. And then maybe years ago, some of you might remember in the East Coast where acid rain was really a big deal and started a lot of people thinking about this. So we identify a problem, then we have to identify causes, and it boiled down to greenhouse gas emissions, and 7 of them is kind of the main ones that we started to look at. And then as a society, we started to identify those sources and the scope by looking at chemical processes, different economic sectors, looking at our activities, where we do those activities, and what societal groups are being impacted by them. And so as a collective group of problem solvers and policy people, we have to identify the aim. What are we going to do about this? So a big, huge aim is to have zero emissions everywhere across all economic sectors. And we want to reverse those greenhouse gas emission trends. And then we're going to identify the goals, and those goals are going to be set up by those economic sectors, by those activities, locations, societal groups. And then we're going to start to identify solutions and set out the scope for that pathway. And it requires a lot of data collection, comparative analytics, and long and short-term planning. And that work is being done by a lot of intelligent people that are working either for the federal government and for the state and universities and other scientists. But the big key premise here is that really we're looking for the least impactful, kind of low to no greenhouse gas emissions alternatives to everything we do. And then we carbon sequester the rest. And that is kind of how you could boil it down, but the problem itself is really big and encompassing. So even as we go through this, we're going to hit on just a key things that overlap with buildings and transportation as architects interface with it. And so kind of backing up again to the beginning of the problem solving part of the process is we learned that the source of our energy impacts climate change, and that the burning of fossil fuels is the main driver of CO2 emissions. And the CO2 emissions is the largest contributor to climate change. So burning of fossil fuels is used for our transportation, like our vehicles, industrial processes. It's used in the generation of electricity itself. It's used in all our equipment and our space heating and water heating. In our buildings, that is, and in our vehicles, actually. So you might ask, okay, so today, why are we going to focus on California for greenhouse gas emissions reductions and talking about this? Well, of course, we live and work and we consume large amounts of energy in California, and we're architects, most of us in California. Some of us might be licensed in other places. But California has a large population and economy. And so it turns out that because of that, for example, California is the largest consumer of jet fuel and the second largest consumer of motor gasoline among the 50 states. And we use a lot of energy. We also produce a lot of energy. So in 2023, California was ranked the 4th largest electricity producer in the nation. But we're also the nation's 3rd largest electricity consumer. And we import more electricity than any other state. So really, California is in a position to be a leader when it comes to looking at electricity consumption, energy consumption, and how to reduce our greenhouse gas emissions. Good news, upshot though, is per capita, we are coming down and have been trending downward in our per capita energy use. So California's population continues to grow, but our actual energy use continues to go down. So when we take a look at the sources of greenhouse gas emissions, and we know that fossil fuels is the majority of where our greenhouse gas emissions come from, we can specifically take a look at natural gas and fuel oil for the heating and cooling of our homes. About a third of it is used for the residential and commercial sectors for space heating through direct natural gas burning. And about a third of that energy is used for, or natural gas is used for, electricity generation. And then another third of it is used in the industrial sector. And almost all of the gasoline and diesel is used by our transportation sector. So natural gas and motor fuel really are the two biggest pieces of this greenhouse gas emissions problem in California right now. So take that same information, and now let's take a look at the economic sectors and the main economic sectors that are responsible for the greenhouse gas emissions. And it's through that we could start to target which parts of our economy can we make a big difference, and what parts of our economy do we need to shift to cleaner fuels and maybe a better way of doing things. And so California's identified these primary sectors as being responsible for the majority of the greenhouse gas emissions, with transportation being at the top of the list. And then next would be the industrial sector, and then commercial residential together has a fairly large impact, and then how we generate electricity itself. So if we take a look at that data and we look at our trends, kind of the good news from what California's been doing for the past 20 years is that our transportation and our industrial processes and our electric power generation has been trending down, meaning it's been trending towards less and less emissions as we start to transition to cleaner fuels for those processes. The one exception on this kind of list of either being flat or decreasing is the high GWP, which high GWP, high global warming potential as a category, often refers to refrigerants. So our refrigerant use in our state is increasing, although these other items are trending downward. So later on, when we talk about appliances and heating and cooling systems that use refrigerants, we'll specifically address what California and the rest of the country is doing on that. Now, when we take those categories and we take a look at subcategories and how that sort of divvied out, and it starts to make the categories for our scoping plan for how we tackle greenhouse gas emissions in California, we can break them out this way with electricity, commercial and residential together, agriculture, that high GWP category, waste, transportation, and our industrial sector. And then each of those could be subdivided further. But when we think about architecture and architects, planners, engineers, the building and construction trade, we realize it's going to cut across many of these sectors, and all together in California, our buildings and construction account for approximately 25% of California's greenhouse gas emissions. And the impact is likely much larger when we take a look at all these sectors, because a lot of our materials are made out of state and they're imported. And that has an embodied carbon impact and a transportation impact that might not be reflected in this. So Project 2030, for example, estimates that buildings construction account for 42% of the global greenhouse gas emissions. And then we also need to include the electricity, the portion of the electricity that then powers our buildings. And before we move on to zero net carbon design in the electric grid, I'm happy to field any questions that come along or put them in the chat, and then Andy will ping me so I can address any specifics to that. But I think that kind of the main point of what we just looked at is part of this big problem-solving process is buildings and construction definitely play a role in greenhouse gas emissions, which in turn play a role in climate warming, and hence California's push to educate architects and all of us on the impact of our design and how can we move towards zero net carbon design in California.
Jennifer, one thing
Yeah.
that I think that we may want to clarify is just that natural gas, when we talk about natural gas, that the burning, I think it's like 95% of what is burned within natural gas is methane directly. And so there's kind of the burning of the natural gas, the methane, but there's also the little bit of leaks that happen within the movement of the natural gas, the methane. And I'm wondering if that's part of what shows up in that GWP, the large, like the leaking of methane, which is so much more impactful in terms of as a powerful greenhouse gas. Am I summarizing that correctly?
Yes, it's in there.
Okay.
It is in there.
Great.
And that's part of it. That is part of the overall puzzle and the overall impacts of that might not show up in California's greenhouse gas emissions as much, but it depends on how much, how do I put it? Well, when we get to the little portion on gas, we'll hit on it, but we import about 90% of our natural gas from out of state, believe it or not. So some of those emissions that are associated with natural gas might be leaking everywhere else but in California. And then in California, we have our own issues with natural gas, methane leaking.
Right, thanks.
Okay, so naturally, as we talk about building electrification, kind of as a strategy, which we're going to hit why that's a strategy for zero net carbon design, we also want to talk about how do we get our electricity and the electric grid. And for California, when we talk about our electric grid, some of the key concepts that come up that you'll hear folks talk about is reliability. And really what they mean by that is the power distribution and the transmission steady and continuous? So can we depend on our electric grid to give us energy, give us electricity? And then when we talk about adequacy, it's really meaning, do we have enough resource capacity to meet demand? So do we have enough electricity to power everything that everyone wants powered? And resiliency, it's specifically referring to can we safely and efficiently power down and then sometimes have to power off during our public safety power shutdown events to prevent wildfire. And we all know from living in California that power lines and wildfires and having high extreme temperature heat waves and having a reliable energy grid is something that is on a lot of people's minds. And so we're often asked the question, well, if we're planning to electrify everything, how is that possibly going to happen with our electric grid? So we're going to talk a little bit about that. And then climate action goals, really, we're talking about, can we quickly implement this zero net carbon electricity production that we're talking about, and do we have the infrastructure to do it? So I want to give a little bit of background to everybody, because I'm sure Andy and I are not alone in some of these conversations that come up, and especially architects, planners. It's going to come up in your conversations, I'm sure, with your clients and your other colleagues. So yes, Department of Energy has done studies on this, and they're saying, yes, our electrical grid capacity to do all these things does need to expand. And it's predicted that we need to expand our transmission capacity by 60 to 125% by the year 2035. So that's only about 10 years from now. So that's a big capacity expansion. And also a lot of folks at the national laboratories like LBA, Lawrence Berkeley Lab, they've been doing a lot of studies on the electricity markets and the policy and the impacts of the grid for having community solar, and what is going to be the capabilities of behind the meter solar plus battery. And what that means is, like, you've got your house, your residence, the project you're working on, and what's the impact when a lot of our buildings, by code, energy code, Title 24, are requiring that we have PV panels plus battery for many of our commercial projects, you know, now a new 2022 energy code requirement. So yeah, the grid needs to expand. And in California, we're part of a grid system that involves the western states and a little bit of Mexico and 2 provinces in Canada. And in California, we're looking at how does California's impact this larger region. And we're looking at, where do we generate this power and how do we generate this power? So there's some great information on the California Energy Commission website that addresses the renewable energy, combined heat and power, nuclear energy, natural gas, geothermal energy, solar energy, etc. In California, when we take a look at where our electricity is coming from, quite a large portion of it, about a third, 31% of California's electricity is generated from natural gas, by burning natural gas in generators. And then fortunately for California, we've done a really good work on getting renewables, more and more renewables. And so about 69% of our energy, electric energy, now is coming from non-fossil fuel sources. And our renewables that are not hydroelectric or nuclear, our wind and solar provide about 38% of the total mix now. So it's kind of the good news about it. But there's a reason we're still burning natural gas, and why we're not 100% renewable energy yet. We'll put a pin in that. We'll come back to that in a moment. And simultaneously, there's a lot of studies going on and work going on strategies for meeting the increase in energy demand, in meeting the need for more capacity without necessarily having to build new transmission lines. And so there's something called reconductoring. So what it means is there's advanced conductors that can be used on these transmission lines that increase the efficiency of the transmission of electricity in the first place. So there's a lot of folks who are working on that, plus people who are working on new types of energy storage, both long-term and short-term. They're working on a diversity of energy resources, including where they're going to be located and their type. And there's folks working on, and by folks, I mean engineers, scientists, and the like, who are working on natural gas substitutions, using hydrogen and biomethane as a way to transition to clean energy. So meanwhile, California continues to add distributed and solar grid scale batteries, solar energy. California leads the nation in distributed generation. So we've got the state that has the most solar on rooftops and building associated PV. So yay, keep going, California. And the good news is that with all that solar, we're able to meet more and more of California's energy demand. But also kind of what goes with that, and you might have heard people talk about it, is, oh gosh, we're producing so much solar energy during the middle of the day that we can't use. This isn't working, and we need something else to happen. We don't need more solar. And the state of California, and a lot of folks would disagree with that. They say, yes, we need to continue building up our solar energy and renewable resources, and we're going to find ways to have energy when the sun goes down. Because essentially, when the sun's up, you get lots of solar energy, and when the sun goes down, we don't have energy. So California has a pattern of energy use over the years that, when each year is plotted as kind of a typical energy use cycle of a day, starting at 12 a.m. and going to 12 p.m. at night, we see that California solar capacity grows, but something called a duck curve is getting deeper. And basically what that means, if you look at the really big, bold black line as a reference, it's saying that we've got a use of electricity that's pretty constant until about 8 a.m. And then solar resources come on board. And so that solar energy meets our demand. So it starts to drop to zero. And then around noon, our need for electricity, the demand, and the solar production are equal to each other. And when the line dips below zero, it means we're making excess solar energy. And then as the sun starts to set, we lose those solar resources. And at the same time, everyone starts to come home and start firing up or powering up their homes. And we get a steep curve that takes us right back up to the top of energy need around 6 p.m., 7, 8 p.m., and then it tapers off again. And this is not unexpected, but some people use it as an excuse not to keep going with renewables. So another way of looking at that is if you plot all our renewable energy resources and the amount of energy they're producing, and we plot it against that green line at the top, which is the demand, we could see that for many hours a day, typically, our solar energy is exceeding that demand. And so rather than curtailing that energy, meaning just ignoring it or getting rid of it, we want to put that energy into something useful. Now, the white areas under the green line, that's really where demand is not being met by renewables. So we have to meet it some other way. And currently in California, what we do to meet that energy demand is we burn natural gas in natural gas peaker plants. And so these natural gas peaker plants provide a rapid response electricity. And the peaker plants are typically working the hardest between 4 p.m. and 9 p.m. during that same time of use, the time your electricity is most expensive. And as we transition to clean energy and to a clean energy grid, we're going to employ other technologies that will be implemented to replace that heavy reliance on the natural gas peaker plants. So in steps, more solar, but with battery storage. And so this plant just opened up in January 2024, or rather was completed. It was semi-operational in 2023, but it's now completed as of January 2024. Located in California, and right now it's the largest single solar plus battery storage facility in the US. And it was a collaborative project with the Edwards Air Force Base. And the solar panels cover about 4,000 acres. And you can learn more about it by following the website. And this type of project with the battery storage is what's going to reduce our reliance on natural gas as a direct burning of natural gas to produce electricity. And so along with that, the solar and the battery storage is expected to expand rapidly. So if you just take a look at our clean energy resources that we had online in 2022, by the time we get up to 2045, you could see that by the chart on the left, that those energy resources are expected to grow substantially. And the battery itself, the graph on the right, just shows just the battery part of that expansion, just to isolate it and give you a visual of the huge amount of increase that we're expecting, tenfold from where we are now in taking the 2023 number, more than tenfold. This is all part of California's clean energy transition plan. Now, we'll kind of put a little pin in that part of it, and we're going to switch to the idea of hydrogen production. And why? Well, because we've got Department of Energy working on this with their Earthshots program, and they're looking at ways to reduce greenhouse gas emissions quickly. And one of the ways we can do this is to take that natural gas that we have, and rather than burn it, we can convert it to, we could take the methane, we could convert it to hydrogen. And the hydrogen, making hydrogen from methane can be a clean process because we're able to control that process and take the carbon and sequester it and use it in other ways, rather than just having the methane be released or burning it and having the CO2 and the carbon and other pollutants be released. So we've got here in California a demonstration project that was really successful at the NASA Ames Research Center at Moffett Field. That's up by Mountain View, California. And we also have project that we're looking at in Southern California, and there's been a pilot project down there at UC Irvine that was successful. And so this next step is to look at real world situations. So Southern California Gas, Southern California Edison, Southern California Gas, San Diego Gas and Electric, Southwest Gas, and PG&E have reworked a recent proposal and resubmitted it to the California Public Utilities Commission March 1st, just 2024 of this year, for a hydrogen blending project where they would blend the hydrogen that they're creating from the excess solar instead of being a curtailment, they would put it into creating hydrogen and then blending that back into the natural gas pipelines. And this reduces the overall greenhouse gas emissions. So this is something I think folks should be aware of, especially because it's happening here in California. And this is currently where a lot of the research is going. Also, in case you didn't hear on the news, this just happened just a few days ago. The company Zero Emissions Industry had used a $3 million grant that they had received from the California Air Resources Board to build the first hydrogen fuel cell passenger ferry in the United States. And it's now open. They're offering free rides. They hold about 84 people. So you could go up to San Francisco and see it for yourself. But the idea is that hydrogen fuel cells could be used to power all types of marine vessels and trucking vehicles where they need a lot more energy, and that energy could be available and they're able to do it safely. The same company has also created a compact, safe way of remotely refueling their vehicles and their vessels, which was one of the big stumbling blocks to using hydrogen. So now back to California and California's plan for grid stability and expansion. And there's a lot of words here. I just printed the whole thing because I thought it was good. I cut and pasted from this report. You can get a hold of the report and read it for yourself. But just the highlights is, yes, a clean electric grid. Yes, buildings need to continue to be decarbonized. We need to decarbonize the industrial sector by using clean electricity and clean fuels such as hydrogen. We've got advanced communication and new advanced controls for our grid system. And we want to make transportation choices that are zero emission, and we're able to plug into the electric grid as a place of convenience for all customers. And that last point really is why we're going to touch a little bit on zero net carbon and transportation, because as architects and planners, we're now being asked to include electrical vehicle charging infrastructure in our design projects. And this is why. It's all part of this big plan. So with that, I'm going to hand it over to Andy to talk about transportation and give highlights on the buildings, and then we will wrap this up for our presentation for today.
Great. And we've had a couple of really good questions come in that I'm going to hold till the very end. This is, we have an hour and a half, up to an hour and a half together today, up till 11 o'clock. But it is worth one learning unit. So I want to make sure we get through kind of the bulk of the content. And then the couple of questions that have come in about kind of municipal operations and how do we look at carbon there, but also the localizing energy production and how does that fit within California's vision. So I'd love to hear and talk more about that as well. So specific to transportation, as Jennifer noted, transportation used to be at gas stations, right? That wasn't part of ours. So let's go ahead and talk about our vehicles and how that is showing up within this space. So we're doing a lot of electric vehicle manufacturing, as you can see, and it's being supported from the federal government to the tune of 1.7 billion from the Inflation Reduction Act. And so some of these are kind of restoring American manufacturing, but it's also, of course, across the United States. Next. And so when we look at some of these, fast charging stations like a Tesla we might see these chargers, we might be charging them, using them ourselves, but we're also not necessarily seeing this back end here that we're showing, where we have these, we have 1.2 million public charges will be needed. So that's huge. But then, of course, all of that infrastructure and the energy in the grid to support it. So they're showing up, they might look like kind of a gas station model in the future, and that's what we might see at a mall. But there's also just a lot of charging that's happening at our offices, at our businesses, at our homes, of course. And this bi-directional EV charging is going to be a significant part, right? So we're all putting these batteries in our vehicles, and they're big. And so could we have systems of charging up our cars, and then we plug our houses into our cars when we get home, and then we can go and charge, and the other way. So it's part of our storage grid stability solution. So that's why the car charging, vehicle charging is showing up in the California Green Building Code. We have a whole on-demand webinar that gives a lot of specificity for architects who are needing this. So really, we're just kind of touching now on what are the foundational requirements within this sector. Next. So there's 3 types. There's kind of an EV capable, which is just conduit only. And that kind of gives a nod to the idea that copper is expensive and valuable. And so we don't necessarily, although we want to make it easy for EVs in the future, we may not be in a position where we want to actually have people put the wires in if they're not going to have an actual charger. And then we have EV ready, which is maybe going to have the power and the energy at the panel and a receptacle, but may or may not have a charger and then the actual charging station. And then there's a few like, okay, what do those look like? Next is that we end up with these kind of level 1 trickle chargers. Those become more helpful for hybrids and overnight when you have a lot. But otherwise, we're starting to look at these higher amperage, 208, 240 volt. There's kind of a low amperage kind at 20 amps, or just kind of a standard at 40 amps. And then, of course, now these direct current fast chargers, level 3. They're not required by code, but code is just had an intervening code cycle. So, and they only do that when things are really urgent. So that's what we're seeing now is just July, as of July 1, there have been some updates. So single family home is actually kind of the lowest bar. You just have to have that EV capable. And that just, again, acknowledges that we're all over the place in terms of who has these EVs right now. So we're trying to have the, you know, not get the cars too hard headed the charging and the other way around. And next.
Oh, Andy, can I point out that at the bottom of your slides, you have that reference to the code section?
Oh, sure.
For folks who want to read up.
Yeah,
That's what
right.
that.
So this is the California Green Building Code. So that's part 11 of Title 24. And yeah, we put down the code reference if you need to look it up, or just reach out if you need the specifics. And so multifamily and hotels, motels, just in the code cycle in 2022, they've added requirements for charging. And then again, this intervening code cycle, it's ramping up. So last month it was one thing, and now we're requiring 50%, it's 40% EV, have to have these EV low power ones, so at least a receptacle, and then 10% EV chargers. In non-residential, there's a table, depends on how many parking spaces you have. Again, there's a mix of EV capable and EV ready, or actual EV charging stations. And they're, again, starting to acknowledge the balance, the range of different chargers that are next. So they talk about having at least one level 2 of these charging stations shall be provided. And that's because they're starting to get the, in the performance, it's almost like a performance approach. Next, please. Is that you could, if you have DC fast chargers, then you that equals 1 fast charger is equal to 5 level 2 chargers. Like that's because people can come in 15, 20 minutes. So you get so many more charges out of the day. You can also go the other direction. You can have low power, that 20 amp charger with just a receptacle. That counts for half of a regular level 2. Or there's even a power allocation method, which is based on the kilovolt amperage, and you can kind of piece together the combination that works best. And so this just recognizes both the urgency in incorporating this, but also how quickly the market and technology is evolving. So in 2022, they added being ready with electrical capacity to charge medium and heavy duty vehicles. That goes back to, as Jennifer talked about, the transportation sector. And then again, intervening code cycle, as of July 1, this requirement has been added to manufacturing and office buildings. So the urgency that comes out. And so now we're kind of back at buildings. This is our, this is where we like to be. This is where our primary education and efforts have been, but hopefully what we have seen is over the course of this, of today's presentation, is kind of that big view and how buildings end up being kind of this central role to so much of what is happening for the climate action and greenhouse gas emissions in the first place. So we'll just look at, this is a little bit of a preview of what we're talking about for the other classes in the series. In terms of what we're trying to do is, of course, supply buildings with clean electric energy. It could be on-site, solar, wind, have our own storage. But it can also be a decarbonized grid, right? So depends on the density and the scale of the operations. First and foremost, we have to design really energy efficient buildings. Then we're going to be using that electric technology, which is heat pumps, super efficient technology. And then we're going to be trying to use refrigerants that have that low global warming potential. And then ultimately, it seemed like icing on the cake, but now we're seeing how integrated and essential it is to choose the materials with low embodied carbon footprint. So kind of all those pieces in the center. And so we, thankfully, we have all kinds of fabulous examples of all electric or nearly all electric buildings. New construction, pretty relatively easy, and ends up kind of being cost effective if you don't need to install gas or gas meters. So unless it's a large scale industrial building, that's pretty straightforward. And then in the existing building sector, we can't be ignoring that as we go. Incremental opportunities in terms of as we're replacing appliances, as we're getting smarter about electrical panels to be able to add on-site solar and batteries to electrify those buildings. And then the other side of that is for our existing buildings, not at the building itself, but that infrastructure approach, all that decarbonizing of the grid, and trying to reduce the carbon footprint of natural gas systems. And so touching on a few examples, again, these are fun ones that you might want to, the links are all in here when you get the slides, so you can go and check them out. This one won the ASHRAE Technology Award for 2024, and it's a school in Wisconsin that's the largest net zero verified education project in the United States. So this is a group that's not only did the modeling, but it's also tracking and fine tuning as they go. They have geothermal heating and cooling, so which isn't usually applicable for our project, but it's a great strategy for climates where that works. And then a ginormous rooftop array and a big battery system as well. The next one is, so the International Living Futures Institute has a living building challenge. It's kind of like LEED certification, but on steroids. It's a big lift to be able to address all of the elements on that, which include zero net energy And so, and this one's also LEED certified. It's the Gulf State Park Interpretive Center. And this one's super exciting because it's also net positive in having the solar array and the battery system. But they've also purchased verified carbon emissions reductions to offset the embodied carbon of construction. So they've done the full calculation to know what was their embodied carbon, and then they've offset that as well. And then this is another living building certification, the PAE Living Building. That's an engineering firm in Portland, and we're the developer. So it's a developer-driven project, and lots of wood for embodied carbon, mass timber construction, and again the historical constraints, but they still have a big solar system, and it's a mixed use. Oh no, sorry, the solar system on this one is on an adjacent project to be able to supplement the full use. And then finally, the last of our examples here is the Air Resources Board leading by example. So it's the largest zero net energy building in the United States, producing as much energy as it uses through that solar array, but it's net, so it's over that course of the year. And it went ahead and took advantage of Cal Green Tier 2 standards as well. So with that, just to kind of bring it back to where we're going with this whole thing, is that California has, through all of that, the process of identifying the problem, looking at the data, having a multi-pronged solution, is that the role of buildings in California is clear. And it started back in the 70s with the establishing the Energy Commission and the Title 24 energy standards. And it, with every 3-year code cycle and some intervening code cycles in between, is that we're just continuing to add first efficiency and then PV requirements, and then the carbon reduction is integrated into all of that. So it's an ambitious goal, but we recognize that the code is well aligned with the big picture goals with what we need to accomplish here. So the heat pump technology for water and space heating and cooling, and then the electric ready for to help with this transition, and the PV systems, and then also improved indoor air quality. As our buildings have gotten tighter, we also need to make sure that we have the ventilation requirements. So those are all part of the big picture goals of the Energy Commission. And it's exciting, right? This is the good stuff, that we're in an industry that can really make a big impact for California's climate action plan. We've got this roadmap about the vehicles and the greenhouse gas emissions, and it also ties into creating green jobs. There's an equity component in terms of how we do this, and it's going to make for a healthier California and a healthier planet overall. What we do matters. This isn't tree hugger fringe stuff anymore. It's just how we build, and it's an exciting time to be a part of this. But be part of this industry and part of the solution. So with that, we are just going to roll through the kind of the closing slides, and then we're going to open it up to questions, a couple that have already been in the chat. Itzel, do you want to say some closing words?
Yeah, no problem. Thank you so much, Andy and Jennifer. That was really insightful. Yeah, so a little bit of comments just about closing. If you have any questions regarding AIA or ICC learning units, please send me an email to my email, and I'll drop it on the chat very momentarily. And then also coming to your inbox, the slide, the recording, and a survey, and just some upcoming courses that we have for the rest of the month of July and August. The second part of the series will be on August 8th, and it will be heat pumps for heating and cooling. So if you haven't signed up, please do so. And with that, I'll hand it back over to Andy and Jennifer to answer some questions. Thank you. Oh,
Right.
one more thing about the energy code coach. Can't forget about that. So if you have any questions regarding the energy code, we have our wonderful energy code coaches to answer questions for you. And we have an online inquiry form and also our number that I will make sure to drop in the chat very briefly as well. Thank you so much.
Great. Thank you so much. We'll go ahead and stop sharing the screen, and but again, you'll get the slides as we go, but then we can go ahead and do questions. If you have to drop off, we appreciate that you're able to participate. But I would like to go ahead and maybe start with this question from Dorothy about localizing energy production and storage. She notes that if we make every residence able to produce and store its own electricity, we increase resiliency and reliability, transportation, et cetera. And she says, you know, isn't that what we're supposed to be doing now? And in a lot of ways, she's right. And it also touches on kind of that microgrid, community scale, microgrid types of technology. Jennifer, I don't know if you have any thoughts on where that fits into the big picture, and maybe Jennifer, we could stop sharing screens so that we can all see each other a little bit better.
Okay, I'm rereading the comment, and it's okay by me if Dorothy wants to unmute and just ask the question or kick off a conversation, because I'm saying it seems for northern if we make it so it's able to produce a stored cell.
I'm just looking at the fact that we're talking about big macro systems, and I don't think that architects or designers have much say over what happens, for instance, in a grid that goes all the way to 2 provinces in Canada. And I was more interested in smart grid and microgrid approaches, which is something that we can have a much bigger impact. So that's what I'm a little bit frustrated by this giant outlook instead of the focus on the things that we can actually impact. Does that make sense?
That's yeah. Okay. No, I see where you're coming from. Yeah. No, that's a really good point. That's that is it's also a piece of the puzzle. That's true. It's also part of what California is looking at and what Hawaii has been working on a little bit more than California on microgrids and how to tackle some of their more local distribution and some of the technologies and the transformers they're using, and how those smart controls on those transformers can help to operate microgrids. California is doing, there's some pilot projects that have been successful. One of them, and they're expanding on it now, is with PG&E. And PG&E has teamed up with the Tesla Powerwall, but also Sunrun for their PPAs, and also people that just have those batteries already under ownership. And part of what they're creating is distributed battery storage. And that may impact you as an architect, but mostly it's like individual homeowner choice if they want to participate in the program. And then that has a lot to do with the type of smart controls or the app that the Powerwall battery has had as they become part of an interconnected, they're calling it a virtual power plant, but really it's an interconnected, distributed battery storage system where the utility can do essentially a demand response in that sense of signal to the batteries that they need that energy to be fed into the grid to actually help with grid stability. So that topic I was going to hit on a bit more when we got to that part of the 5-part series.
Right, and
And
that'll be the fifth one, is where we're touching on the PVs and the energy storage systems. And it's a great point, Dorothy, and I think that we could go ahead and plan on making sure that we're incorporating more of that microgrid kind of conversation, because that does certainly have relevancy.
right, and then California is really kind of two-pronged in the sense that California is leading the nation in that distributed solar energy, meaning solar energy that's all over our buildings, and it's kind of incorporated into the energy code. So as designers, as we do new construction, we are required to either show the project's exempt or the new residents include solar, and the new non-residential include solar plus battery. So it's definitely part of the solution, is just completely baked in now to our energy code. And it also kind of pushes some of that distributed energy burden onto homeowners or building owners to take care of it, whereas some of the utility scale grid solutions that we hit on today is they're able to roll out the amount of solar energy and batteries needed very quickly, efficiently, cost effectively, in a large scale. And otherwise, the amount of solar on a distributed scale on existing buildings, yes, it's being done, but the rollout is incredibly slow compared to what can be done on a grid scale. And in order for California to meet their goals for clean energy, we need both distributed and a massive rollout on the large scale. And that's why we talked about the large scale today.
Great. Thanks, Jennifer. George had a question. He's also provided a lot of great discussion and feedback. Thank you, Dorothy. George, though, earlier, did you want to follow up and ask your question about the kind of a city water department and accountability there? Anyway, I thought it was a good question. Do you want to unmute and say
Yes,
maybe where that's
you.
coming from?
Thank you, Andy. Thank you, Jennifer. Really appreciate your great classes. I really enjoyed this, and I appreciate your effort. I noticed I asked many months ago our city water department to calculate and publish the average embodied carbon per 1,000 cubic feet, as that's the unit that we use for our water bill. But I feel like our water bill should say on it, what's the embodied carbon for what we're doing? Because we're starting to get into things like considering desal and the Water Pure project, even direct potable reuse. And all of these things become very energy intensive. So I haven't seen them publish that number. And I wonder, have you been able to get the San Luis Obispo folks to share that information or even calculate it? And if not, then how do we get leverage on the water utilities to kind of induce them to share that information or induce them to calculate that information and then share it?
Yeah, I think it's a great question, and you're asking it, I believe, in the right context in terms of like what choices are we making. I remember watching a study for Los Angeles when they were trying to figure out what makes sense in terms of recycled water and how energy intensive it was to clean the recycled water. But then when they went through and did the exercise of comparing their other water sources from a carbon footprint, the pumping that it takes to get it up and over the hills, you know, they were kind of starting at the water treatment plant type of thing. But when they backed it all the way up, then the recycled water plant made a lot more sense to pursue in that way. So I think it's super interesting to call it. But no, we haven't incorporated in the same way. What we have in the city of SLO is not the is only the operational carbon for the water treatment plant and wastewater treatment plants themselves. That's what's in our our climate action plan. So yeah, so I think it's fair to ask about at least tracing where that water is coming from when we are making other procurement decisions. I don't know if that's helpful or if anybody else has feedback on that one.
Andy, I see that we have some comments that are, I guess the next couple of comments I saw have a lot to do with the components of our solar systems and our battery systems, especially in terms of like how are they created, where the lithium comes from, assuming the battery is a lithium battery, and how do we deal with recycling. So these are in the comments, these are known concerns amongst the scientific community and the folks that are doing a lot of research. There's really exciting research on alternative battery chemistries right now, and some of them are coming to market that do not depend so much on lithium. And California is in the US is looking to have our own lithium resources for situations where we need really high power density battery, which lithium currently still provides. But if you're not familiar with it, there is the Redwood plant in Nevada that is recycling batteries, and they're finding, and we need more recycling centers like this, that it is much more cost effective to essentially mine the existing batteries than it is to mine new materials. And so part of the big picture is that we absolutely have to have, and so as any influence that all of us as citizens can have, I recommend that we promote that and look at supporting places and projects that are looking into the PV panel recycling and the battery recycling. And there is some innovative work being done with PV panels where a company has figured out a cost-effective way to kind of separate the top part of the panel from the bottom part of the panel and to reuse those materials and remine them. But you're right, the comment that if we just ignore that stuff, it's completely not solving the problem, right? So when you look at people, buildings, how we get our energy and everything, then it really does need to include all of the materials we currently use in our the way we live and what we do with them. And I would argue that right now we don't do enough of taking care of the materials we already create. So I can see your point. You don't want to add to it, but it needs to be part of the solution. And so I think there is really interesting, really exciting research being done. And a lot of it is being done through a lot of the grants that were funded through our federal government, through the Department of Energy and through the Build Back Better and the IRA. So I just think we need to continue that and to continue promoting those technologies.
And Soham kind of weighed in on that as well in terms of if we're extracting and, you know, what are the trade-offs compared to other pieces. So great conversations. And I think it also brings us back to some of our original jobs of architects, is designing buildings that are low energy use in the first place, right? That have passive ventilation and great daylight and are able to, you know, have resiliency as standalone with as little energy as possible in the first place, with durability of materials, just kind of the better buildings that are stewardship, good material resource, environmental stewardship overall. We're coming up on the 11 o'clock hour. I want to honor everybody's time. Does anybody else have a question that they want to chime in on or unmute or other comments before we sign off?
Oh, I do. I want to comment because I think it's true what Soham put in the chat. I mean, okay, we're talking about recycling of our PV panels, figuring out ways to reuse and recycle the wind blades, and a lot of us who carry about environment, we're think about these things. So we go, oh no, we don't want to be a part of having a lithium battery in our electric car. Yet, okay, so the supply chain and recycle chain, but in my old car, my gasoline was never ever recycled. It never got recycled, and it constantly emitted greenhouse gases. And the place that it came from. So I see moving forward into having materials that can be recycled, and just making sure that us having an influence with our policymakers, that is part of the solution moving forward.
Hi, Jennifer. Hi, Andy. Thanks for the great presentation.
Nice to see you.
I think that's a good point. I just wanted to bring that comment to a close. For context, it was a client that wanted their building to be sustainable. And as we were talking about what that looks like, they were like, oh, I've been seeing such terrible stuff coming out from the mining processes of lithium, which is a very fair concern. But they were like, I think this is why we should go with natural gas. I think because they weren't reminded of the impact of fossil fuel reduction, the devastation of all that, which I think you all did a great job pointing out in this presentation. They sort of had that blind spot of like, oh, like we must do the most sustainable thing. And does that kind of like stop progress? And that's something I've been thinking about recently. And I think I just want to share this little diagram about the circular economy, because I think it makes a great point of like, we will always have to extract to some level. But you know, the choice of how much do we extract that is non-renewable versus things that are like bio-based and renewable. But just a funny little anecdote of like, they were so interested in sustainability that they were so focused on this lithium thing that we had to like sort of step back and point out the context of, well, we don't measure the impact of fossil fuels in the way we're being so stringent about renewables. Is it fair to have that type of comparison? Yeah, here that like, there will always be some, on the right-hand side, extraction of finite materials. So how can we minimize the extraction of finite materials and keep it in the supply chain, and prioritize the use of renewable materials and keeping them in the supply chain? And I think that's really shifted my perspective on this lithium conversation, because you know, as we make more batteries, and if the idea is that every home has a battery, like that's a lot of lithium to have to figure out, you know?
Right. And so there's also now saline battery chemistries. And for a lot of residences and buildings, don't necessarily need a high density battery like a lithium battery that you would want for a vehicle, for example. And that's something too that our clients weren't aware of. They're like, oh, you mean lithium ion chemistries and not the only battery out there? And that's true. So
yeah, I think it would be great to hear more about this in a future topic, especially given like the comments from me and from George, I believe Melissa. I think, yeah, that would be interesting to know how it applies to a building, not just at the macro scale.
Great. Great conversation, everyone. We so appreciate that. I think we're, unless there's any last comment, I think we'll go ahead and wrap it up for today. Each of these in the series are individually registered. Again, if you joined late, there is an AIA San Luis Obispo. The chapter here is hosting an in-person class starting in October over 2 mornings. So you're welcome to join that one. Instead, it's the same content either way. So great. Thanks everyone for joining us, and we will catch you next time.
Thank you, everyone.
Bye.